Question number 9. The equation 3 divided by x plus 5 is equal to minus 2x plus c, where c is a constant, has no real roots. Find the range of possible values of c. Now the first thing that we need to do in this type of question is that we need to rewrite the given equation in the form of ax squared plus bx plus c is equal to 0. Alright, so if we observe here, we have two terms on the right hand side, and if we bring them on the left hand side, we will have our equation equated to 0. So we have 3 divided by x plus 5 plus 2x minus c is equal to 0. Now let's take x as the common denominator. In other words, x is our LCM. And now we have 3 plus 5x plus 2x squared minus cx, the whole divided by x, is equal to 0. So we can multiply by x both sides. So we multiply left hand side by x and the right hand side by x, and these x's cancel here, and we are left with 3 plus 5x plus 2x squared minus cx is equal to 0. We can rewrite by taking the x squared term in front. We have 2x squared plus 5x minus cx plus 3 is equal to 0. If we observe here, we have two terms containing x, so we can factorize by removing x common out. So now we have 2x squared plus x into 5 minus c plus 3 is equal to 0. We can rewrite this as 2x squared plus 5 minus c x plus 3 is equal to 0. In the first part of the question, we discussed that we need to write our equation in the form of ax squared plus bx plus c is equal to 0. And in this part, we have already written it in the form of ax squared plus bx plus c is equal to 0, where our a is 2, our b is 5 minus c, and c is equal to 3. Alright, now let's go back to the question. The question says that we have this equation which has a c as a constant, and the equation has no real roots. So when we have the condition of no real roots, we should know that it implies that b squared minus 4ac is less than 0. So let's rewrite b squared minus 4ac by substituting the values that we have found. So the value for b that we have is 5 minus c. So we write 5 minus c the whole squared minus 4 into value of a is 2 and the value of c is 3. This is less than 0. Let's expand this. So we have 25 minus 10c plus c squared minus 24 is less than 0. So this is equal to c squared minus 10c plus 1 is less than 0. Now we have got an inequality with c. Alright, so this inequality will help us to find the range of possible values of C. Now, whenever we have an equation or an expression which is in the form of ax squared plus bx plus c, we can also call it as fx or y. So in other words, we are looking for this f of x being less than 0 or the y value being less than 0. This is a very important point to understand. When we draw our inequality, we are looking for the y values that are negative, and that's why it is less than 0 here. Okay, and this part represents our fx or y. Okay, so moving on, we have c squared minus 10c plus 1 is less than 0, and as we discussed, this is an inequality. To solve this inequality and to find the range of values of c, we must first find the critical values. And to find the critical values, we must equate this to 0. So, to find the critical values, we equate c squared minus 10c plus 1 equal to 0. And we need to solve this. So we can solve this by completing the square method. We have c minus 5 the whole squared minus 25 plus 1 is equal to 0. C minus 5 the whole squared minus 24 is equal to 0, and c minus 5 the whole squared is equal to 24. We can take square roots on either side, and we are left with c minus 5 is equal to positive or negative root of 24, which is 2 root 6. And hence the value of c is 5 plus or minus 2 root 6. So these are our critical values. Okay, so these values will help us to find the range in the inequality. So let's draw the graph. Since it's a quadratic graph, it will be U-shaped. This is our x-axis. So we have 5 plus 2 root 6 here, which is this point, and 5 minus 2 root 6, which is this point. Okay, so f of x is equal to y, and we are looking for the y values which are less than 0. So clearly, if this is the x-axis, these y values are greater than 0. These y values are greater than 0, but these y values are less than 0. So all these values are the values that satisfy the condition of the question. So we have the values right from here till here. So if the values are represented by c, c is greater than 5 minus 2 root 6 and less than 5 plus 2 root 6, because to the right of this, these values will become more than 5 plus 2 root 6, and here the values will become less than 5 minus 2 root 6. And since we do not have any provision for positive values, we cannot have any values from here and here, and our answer is only the values which are in the lower part of the curve. Alright, and hence we have found the range of possible values of C.